Alright, let's take a look at a problem involving normal and tangential components. I think it's homework problem 12 on 16. Okay, we have this car and they give us its acceleration right here as a function of time, or its increase of speed, they say. So that would be like a tangential, because we're not only going on a straight path, but then we're going to start going on a curved path. We can go ahead and call that its tangential acceleration. It's a 0.05 t squared, feet per second squared. Okay, they want us to find the magnitude of the velocity and the acceleration if it started from the origin at rest at t is equal to 0 to whatever these things are after it's traveled 550 feet. 300 of that feet from the diagram is a straightaway, which makes 250 feet of it a curve. Alright, let's see what we can do. Okay, we're given that the acceleration, or v dot, is equal to 0.05 t squared. Let's use the definition that acceleration is equal to dv dt. Separate those variables to look like a dt is equal to dv. Alright, substituting dv, I'm going to flip it around real quick. dv is equal to, let's put in the acceleration, 0.05 t squared, and dt. Excuse me. We can integrate from t is equal to 0, that was an initial condition, to some t, or some v. V was 0 at rests. And then t is equal to 0 would be over here, to some t. Okay, what do we get? We can integrate and get velocity as a function of time now. Get a decimal, 0.0167 t to the third rounded. And now that's in feet per second. Okay, notice we cannot use constant acceleration equations or velocity equations. The acceleration was given as a function of time, the velocity is a function of time. So we need to, if we want to figure out how fast this thing is going, they didn't give us the time to plug in. We need to use another definition, the definition that the velocity is equal to ds dt. Rearranging that, I get ds is equal to the velocity times dt, and we can substitute for v. Get ds is equal to the velocity dt, and then we're going to integrate both sides. We started from s is equal to 0, and we want to know about at 550 feet. Let's just go ahead, we can put an s in. I like doing it, getting a generic equation, and some 0 to some t. Okay, integrating that, we get s as a function of time, 0.004167, and that's times t to the fourth. We set this equal to 550 because that's when they were concerned, and we can solve for t. It's going to give us 4 solutions. I believe 2 are the same and both positive. We take those solutions, or you think you get 2 real and 2 imaginary. One of these is positive, one is negative. We want that positive one if that's the case. So solving, we get 19.06 seconds. And that's how long it takes. Now they didn't ask for that, but we're going to use that and plug that back into our velocity. If it traveled for that long and we have a function for its velocity, velocity at t is equal to 19.06, we can figure out how fast it's going, and that's one of the things they asked. So this will be the 0.167 t to the third evaluated at t is equal to 19.06, and we get a velocity equal to 115 feet per second. Alright, that's one answer. and that's the magnitude, the velocity, or the speed. If we wanted to figure out the vector, we would need to figure out where on the arc of its path would a radius of curvature of 240 feet, what angle would that give us? And we'd have to add the angle in there. So we could figure it out, but didn't ask for it. But what we can do is figure out its normal and tangential components of acceleration now. They asked for the magnitude of the acceleration. Okay, the acceleration is going to have some tangential component at this point. And since we're going around a corner, it's also going to have some normal component of acceleration. We can figure out the tangential component of acceleration by taking the function that we began with, 0.05 t squared, and evaluating it at t is equal to 19.06. We get, I don't remember what we get, I didn't write it down actually. The normal component of our acceleration can be found by taking the speed at that instant and dividing it by rho. Well, rho is a constant radius. We have the speed as 115 feet per second. We need to square that and divide by rho, which is 240. Now, whatever this number is, we can take both of those and find the magnitude as such. So whatever that comes out to is your answer. Thank you.